So today, Common Core Standard, we're going to be solving radical inequalities. 1, 12, 18. Okay, the whole idea, this whole word radical, okay, hopefully you guys are remembering radical means it's a root. Radical is just some root, nth root of x or whatever. That's radical. Whether it's a square root, a cube root, it's a radical, dude, you know. So those are square roots, cube roots, or any kind of root, okay? And the inequalities is the less than, greater than. It's the Pac-Man symbols, right? So the thing about inequalities, it says, okay, everything less than. Well, that could be a lot of numbers, right? Not just equals 5, but less than 5, which means that's a whole group of numbers. So we can put our answers in terms of inequalities. Hello, yes?
Please excuse the interruption. If you were one of the students going to the mountaintop play, the bus is here, and so you'll be meeting in between the high school and middle school. Thank you.
You're welcome, Mr. Hoya. So anyway, back to this. So before I do anything, I know there's going to be a range of values, okay? And with the range of values, we have to be a little bit careful that the very bottom range keeps us from dividing by 0, okay? So I'm going to start right with what's inside and say to myself, well, for sure 2x plus 4 must be positive. This has got to be positive. It has to be positive, because if it's negative, divided by, I'm going to take the square root of a negative number, bad, right? So I'm going to say, let's make sure this is greater than or equal to 0. Okay, that's what's going to keep it positive, right? So I'm just going to solve it. This is easy to do. We just have to remember that these are not difficult problems. We have to remember, though, there's a range of values. So minus 4, 2x is greater than or equal to negative 4, right? Divide by 2, and x is greater than or equal to negative 2. Okay, so that's the low end of the range, right? Now, who are you looking for? Oh. So then the high end of the range is to actually find out when it's less than 4, okay? So then that's the low end. So let's look at the other part. So there's two parts to this, really. So the other part is just find out when the entire expression is less than or equal to 4. So we'll just solve this. We'll take the square root of a 2x plus 4 less than or equal to 4, and we'll solve, okay? So 2x plus 4 less than or equal to 4. And we'll just solve, okay, what x values are going to be less than 4. So we'll just solve like we always do. So first step, square both sides, right? Because that'll get rid of the square root, right? So if I square both sides, I'll get a 2x plus 4 is less than or equal to 16, right? Minus 4. How about 2x is less than or equal to 12? Divide by 2, x is less than or equal to 6. So what we have are all of the numbers between negative 2 and 6 that will work. They'll work. Any other numbers without that range is not going to be a solution. So in set notation, I could say negative 2 is less than or equal to x, which is less than or equal to 6. Or if you like interval notation, which I kind of like interval notation, it's easy to write, bracket, because of the equal sign, remember that? Negative 2 comma 6 bracket, okay? Thumbs up. Seem pretty easy. I think you got a better understanding why we have both at this point now. Okay, example 2 is no different. Example 2 is just, we can just solve it. Go minus 2. We'll get the square root of x minus 3 is less than or equal to 3, right? Just solving it. Okay. Square both sides. X minus 3 less than or equal to 9, right? Plus 3, we get x is less than or equal to 12. Okay, but, hey, Mr. Hoya, come on in. But, Mr. Hoya, remember this? It's not that simple, because we got to also make sure that, what if x were 0? That's less than 12. But what if x were 0? Not going to work, huh? Right? Bad news. So we're going to make sure this expression always stays positive, right? So there's two parts to this. So the second part, okay, because we've got a range of values, we're going to make sure that we take what's inside, right? We're going to take the value inside, take x minus 3 and say, well, we better make sure that that stays positive, right? We need that to be positive, okay? So we set it greater than or equal to 0. Okay, so plus 3, we get x is greater than or equal to 3. So we really do get a range of values. So any values between 3 and 12 are going to work, right? Anything outside that range is going to give us a problem. We know 0, we took a look at 0, right? 0 minus 3, think about it, 0 minus 3, negative 3, square root of negative 3, right? It's not going to make Cookie Monster happy, is it? Okay, so then finally our answer in set notation would be 3 less than or equal to x, which is less than or equal to 12, or interval notation, which I like interval notation better, bracket because of the equal sign, 3 comma 12. Okay? Thumbs up? Thumbs up? Does it make sense? I mean, tell me, does it make sense that you got a range of values? I know. It's Friday morning choir, right? So I was like, yeah, I got to understand. Okay. All right. Now, how about example 3? How about example 3?
Interesting.
Huh?
Example 3 is interesting.
Well, it is interesting. That was a great comment. It is very interesting. What do you think? Anybody have any comments besides, what do you think, Leora?
I mean, you could solve it and say x is greater than or equal to -1.
Let's do it.
Solve it.
Sure, why not?
You
Let's
have
solve
to
it.
find the other side.
Yeah, let's solve it. So if I go ahead and cube it, right, and cube it, you guys okay with that, right? So, I mean, that makes sense because the cube will cancel the cube root. And I get x plus 2 is greater than or equal to 1. And Leora, you already had, you get minus 2, right? Minus 2, x is greater than or equal to -1. Okay, so let's figure that out. If I put in -1, so take my answer, put in -1, -1 plus 2 is 1, and the cube root is 1. So let's think, how about 0? 0 is bigger, right? How about 0? Put in 0. 0 plus 2 is 2, cube root of 2, that's bigger than 1, right? Do we have, well, okay, what about what's inside? What about what's inside? What if this value was, let's just try something, okay? So we say greater than -1, huh? Well, ignore that because that would still be greater than. All right. What do you know about cube roots? Yes.
It can be negative.
Thank you. I was waiting for somebody to say that, right? So is there a problem? Do we need a range of values? With the cube roots can, so we know that cube roots, they can be negative. So here's my answer. It's all of those numbers. There's no range of values. It's just greater than or equal to -1, right? Because cube roots can be negative. Okay, you guys ready to turn the page? How am I doing? Okay, turn the page. Oh, we got a graph. I like it. I like it. Okay, so all right, let's go back to what we know. Okay. All right, so if I've got, say, y equals the square root of x. Do you remember what that looked like, you guys? Do you remember how we graphed that? Put this right up here, just our parent function, right? Anybody remember what that looked like? We did that a couple of days ago. Simon says yes. Simon, how's it look? Give me a hand motion. Yep. So I put down 0, 1, 4, and 9. Why do I like those numbers so much?
They're squares.
They're squares, right? And now the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And Simon, you were right. Looks like that, doesn't it? Okay? All right. Alexis, let's see if we can make this easy for you, okay? So when we did these, the last time we did these is we were talking about, okay, well, we got to make sure we have an endpoint. Remember opposite? So we have an endpoint. Endpoint. Remember we talked about the opposite? It's the opposite of the inside because that's what would zero it out, right? Endpoint is going to be at -1, -3. Okay, there you go. And let's just take our parent function and put it down here. Okay, so 1, 1, 1, 2, 3, 4, 2, because the square root of 4, right, is 2. Go back to my endpoint. 1, 2, 3, 4, 5, 6, 7, 8, 9. Off the page, that's okay. And then 3, okay. We just need the general shape, right? There it is, okay. All right. So we need less than or equal to. We need all the values less than. So less than we normally shade below, right? So we shade below, right? Okay, but we got to be careful when we shade below. You know why we got to be careful? We have to be careful because right at this end point, if I go any further back, so if x were equal to -2, what's going to happen? If x equals -2, what's going to happen? Can't, right? So when I shade this, I'm going to shade below, but I'm going to make sure that as I shade, that I don't put any values over here because these are going to be my making Cookie Monster unhappy values, right? Right? You might, Mr. Hoy, you must be wondering why Cookie Monster is unhappy. We'll have to. You know that one?
No.
You don't know that one? Okay, we got to show you. Hold on. Time out for a second. Guys, good about it. All right. So we're studying rational and radicals, right? So, all right, here we go. What is 0 divided by 0?
Imagine that you have 0 cookies, and you split them evenly among 0 friends. How many cookies does each person get? C. It doesn't make sense. And Cookie Monster is sad that there are no cookies. And you are sad that you have no friends.
So Cookie Monster, because he's a great mathematician, agrees with square roots too, okay? So if you're going to make Cookie Monster unhappy, don't do a square root of a negative number either. Isn't that pretty funny? Yeah. Okay, now, example 5. So, example 5 is a little bit more difficult. Let's see, do you remember how this graph, let me put this down, how 1 over x, y equals 1 over x. Does anybody, just for the heck of it, does anybody remember what this graph looks like? Anybody? I mean, it was like a couple of weeks ago. Anybody? Simon says yeah. Simon, what does it look like? Give me a... Yep. So the parent function, totally right. Yep, parent function is, its parent function looks like this on the side. Nice job, Simon. It looks, you guys remember this now? All right. It's that one. And where is Cookie Monster sad? Where's Cookie Monster sad?
2.
Say what? No, yeah, we'll forget. Okay, yeah. Where's Cookie Monster sad? And 0, right? So we'll have a vertical. We're going to have a vertical asymptote. Remember the vertical asymptote, right? So we have the vertical asymptote there. And we'll have a horizontal asymptote here. So what we're going to do, before we do anything, to graph this one, we'll take our parent function. And we'll move our asymptotes to 2, -2. Does that make sense? Opposite the inside, because that would 0 it out. Of course, we'd have an asymptote at 2, right? So, Leora, I'm going to take and put exactly what you said first. I'm going to go x cannot equal 2, all right? Before I do anything, cannot equal 2 because 2 minus 2 is 0. Cookie Monster is sad. Okay, so we don't want to do that, okay? So we're going to have a vertical asymptote at 2, so we're just going to move our asymptotes to that point. So our asymptote, it goes over to 2. And then it goes down to 2, so my asymptotes are going to go right in here, okay? Okay. How am I doing? Thumbs up? Thumbs up. I know it's Friday morning. I love Friday mornings. You guys are always so quiet. Monday's always a different story, huh? Okay, and then let's just put our parent function into that, into the asymptotes, okay? So we got a general shape. Now, with inequalities, if we want less than, it's a little bit confusing because we really are going to have 1, 2, 3, 4 regions, right, to shade. So the question is, where are we going to shade? Well, we can test. We can test a point. So we can test each region. So what I'm going to do is test a point. I'm going to test each region. All right, well, what does that mean? Well, let me see. I'm going to pick a point. Let's see. How about this point right here? I'm going to pick that point right there. I'm going to pick a point here. Oh, I'll probably pick, let's pick an easy one. Let's pick that point because it's got a 0. Let's pick an easy one. Actually, I should pick easy ones on all of these. Well, like I'll pick this one. You know why I'm saying that's an easier point to pick? Why is that easier than that? Because you got a 0. I like 0. 0 is always good. Unless Cookie Monster, unless we divide by 0, then that's not good, right? Let me pick this point here. Okay, so we test all these regions. So what I want to do is test them. So this is the point at 1, 2, 3, 4, 5, 0. This is at the point 0, 2, right? This is at the point 0, 1, 2, 3, 4, 5, negative 5, okay. And this one is at 1, 2, 3, 4, negative 3, 4, negative 3. Okay, so all right. So how do we test them? So what we can do is plug them in. So let me go to the blackboard, whiteboard, what do you want to call it? So let's test it. So test, first of all, let's test 5, 0, okay? So we're going to put 5 in for x, 0 in for y, and see if we get a true statement. A true statement, if I plug them in, what's a true statement? Is that this value, which is like our y, so let's change to y. A true statement is going to be when this value is less than or equal to this value. Does that make sense? Okay, that's going to be a true statement. So let's check it out. Let's put in the 5 for x, okay, and we'll put in the 0 for y. So if I simplify this, I get 0 is less than or equal to 1/3 minus 2, right? Is that true? It's not true. So we don't want to shade this region. Kind of makes sense. Less than, you'd think it'd be below it, wouldn't you? I mean, that kind of makes sense. I mean, that's going to be negative 1 2/3. That's not going to work. So this region is a no, right? This region is a no. We're not going to shade that region, okay? All right. Okay, let me keep going with this. Okay, so let's test another region. Probably this one. Do we think this might work? Because it's less than. Let's give it a try. Okay, so 4 goes there, negative 3 goes there. So let's see. I've got a 1/2 minus 2. I get negative 3. So I'm going to get a negative 1.5. Is that greater than negative 3? Yeah. So that means I do want to shade. I do want to shade this region in here. Okay. All right. So I'm below my curve. I'm shading below there. Okay. Now let's try the next region. Okay. Let's try the next region. Okay. So the next region is here. Let's try 0, 2. So I'll put 0 in for x and 2 for y. So 2 is less than or equal to negative 1/2 minus 2. So is 2 less than negative 2.5? Is 2 less than negative 2.5? No. So we don't want to shade this region, but kind of thought we wouldn't because less than kind of made sense to me. So I'm not going to shade that region. What am I left with? This region, 0, negative 5. Let's test that region. Okay. All right. 0, negative 5. So negative 5 in for the y. 1/0 minus 2, which is going to be negative 5 is less than or equal to negative 1/2 minus 2, which is a negative 2.5. So is negative 5 less than negative 2.5? Yeah. Yeah, so let's shade that region, okay? So we're going to shade this region, okay? So now, all right, there we go. That looks pretty good. Okay, we've got all that region shaded. So it sure looks like it might be something like this. Now, it's a little hard to get this. So now, what if, I love doing this to you, what if the calculator would do it for us? You wouldn't have to test any regions, right? So then why would Mr. Davies make you do it the long way? Maybe so that you know what's going on. You know that those are all the values that are going to be less than or equal to my x value. So let's go ahead. So I'm going to graph it. Okay, y equals, right? Oh, I'm in polar. Somebody's been messing with my calculators. It's always so much fun when kids are playing around on my calculators. Okay, quit. All right, let's try this again. Y equals, clear that. 1, let's see, my equation is 1 divided by parentheses x subtract 2. You guys have a calculator? Do you have a calculator? Anybody need a calculator? Calculators? You guys want to grab a calculator real quick? Calculators? Calculator. You want to try one? No, really. Calculators. Okay, swatch, calculator. You guys got one? Calculator. You're welcome, Big Llama. Okay. Okay. All right. Calculator. Rudy, your timing is actually pretty good because we're going to, after this, we're going to see if Tide works. And having you here might be a lot of help. We're going to try it so that Tuesday we can do a pretend test. Okay, subtract 2, okay. Okay, so go ahead you guys and put that in, okay. Alright. Put that in, I'll wait for you. And then what I want to do is this. Do you remember a long time ago we talked about how these calculators will shade for us? They will, right? Remember how we did this? And what we want is less than. So do you remember how I did this? I'm looking for enter, enter. That's greater than. That's greater than because the shaded arrow's pointing up. That's less than, okay? Do you remember? Anybody questions? Anybody need any help? Okay, Leora?
Mine doesn't do that. It's like, see, the way you do it, and just enter is just a line.
Oh, really?
Yeah.
Wow. Okay. Grab a different calculator, and I may have to reset your calculator. That's weird. Or just watch Sarah. Okay. Everybody okay? Good on this. So if I graph, before I graph though, let's pick a window. Before we graph, let's pick a window, and I think the window that we should use should be this window. You agree? I mean, let's use this window. Makes the most sense because we've already graphed it. So I'm going to go from 1, 2, 3, 4, -4 to 1, 2, 3, 4, 5, 6, -4 to 6, right? So let's use the same window as our graph. So -4 to 6, right? Scales by 1. My y's, let's see, we got a 1, 2, 3, 4, 5, -5 to 1, 2, 3, 4, 5. Let's go -5 to 5 on my y windows. So let's go -5 to 5. And then we should get the same picture that we have up here, right? Savannah, was that you just stretching?
Yep.
Okay. And graph. Cool. Look at that. Hi, Landon. Come on in.
Oh, hi, Landon.
So, check it out. So, we're pretty smart because we were able to do it by hand, but wouldn't using the calculator be a lot easier for you? Right? Okay. So, go ahead and clear that. Homework. And you've already done 23, but I want you to do it again. So, we're going to do 2 pages. Page 625, 43 to 46. We can make this odd. It's Friday. We can make that odd. We can make this. No, that's because that's only 1, 2, 3 problems. No, we'll just keep that there. Okay, we'll change that to odd. Okay. That's only 2 problems. That's not that many problems, you guys. I did turn your blue card in.